Thanks, Peter, for the opportunity. Actually, there is another interpretation. Like sometimes ignorance is a blast. Because I don't know any of those engines. I came from Power BI and Excel background, and that's an advantage. Like I don't have any bias, so I start just searching for those engines. Probably you guys are familiar with Pandas. The other engines, anyone using Polars or DuckDB? Duck, great. Polars? Yeah, of course. Python, of course. Bit myself, so I work for Microsoft, but this talk is not specifically about Microsoft offering. I came from Power BI, been Power BI user. Who use Power BI? Of course. I'm civil engineer, so I'm not an IT, and that's why I have different perspective on those stuff. I have a blog, and I'm very active on Twitter, and feel free to connect on LinkedIn. So just for historical perspective, just to understand because I think we're in a very interesting era in data platform. So the evolution of data warehouse, like the early days, you have just one box, everything together. So storage with compute, and this is how it started. But then later, then the cloud arrived, and one trick is they found is the use of compute and storage is sometimes independent. Sometimes you may want to store stuff that you don't query all the time. So the idea that in order to store more, you need to install more compute didn't make much sense. So for practical reason, they come up with this idea that the compute is separate from storage. So you can turn on and turn off your compute, but your storage is always there in cloud storage. That was in the early 2010. Anyway, like Snowflake and BigQuery, everyone will say that they've done it first. I think it was BigQuery, just for historical reason. Then in 2017 to 2023, this is not like real clear dates, but that's my own interpretation that like we start having this open table format. So it's a natural evolution. The first thing we had those cloud storage. I say storage is independent, but now because of competition, new vendors, especially they came from the data lake tradition, they said, you know what, like even the storage is open format. It means you can use any compute. But personally, and they called Lakehouse, but personally, I couldn't stand Lakehouse. I didn't like it at all for a simple reason is, they say it's open table format, but in reality it works only with Spark and Trino. So it's really tied to these big engines. And again, I'm from an Excel background. The idea of using Spark just really, for me, doesn't make much sense. But then something changes. Okay, obviously I work Microsoft, so there's a big bias. But I think like in 2023, Microsoft released something called Fabric, and it's like a data platform, like Snowflake, Databricks, and BigQuery and AWS. And what I found it interesting is it wasn't tied to only Spark. There was like a lot of different engine, and they were native engine. It means they're written in native code, like C++. And basically, the engine is really independent from the storage format. Obviously, Spark is still, I would say, the core writer, but it's totally okay not to use Spark and just use those open table format. And for me, I love it for some reason. It's just nearly for philosophical reason. For me, again, even if your table format, even if it's tied to an open source engine, but just one engine. So for me, that's not real progress. And that's, I think, we're in this era. And basically, any engine can read from those open table format. Obviously, they're not all equal. Not everything is implemented. But like currently, it's way better than it was like 2 years ago. So but why it's interesting is that because now we have those lake houses, it means there is an opportunity for new engines to make an impact. Because now it's much easier. Like all you have to do is just focus on calculation, on running queries, and the storage will take care of the rest, which is basically storage and catalog and the rest. So in a sense, the more storage become sophisticated, the more new engine can have more impact. This is, as I said, like a lot of vendors are offering a lakehouse. That's not like specific to Microsoft, but again, I have to say this contractually. So we have yeah. So we have this offering. If you see Databricks is smallest, the same. The only difference is we have a lot of engines. It's Microsoft's a big company, and they have different, those engines, they have like probably from different, even divisions, using different code, and they have nothing in common, except that they all talk to the same lakehouse, same storage. And people may say, just a marketing trick, they group some engine, and they said, like, under one offering, they said they're all together. But actually, it's not. Like I know, for example, data warehouse, they had to literally take an existing data warehouse, which is Synapse, and remove the storage layer and make it work with Parquet, and it was a massive amount of work. I think even the guys, they underestimate how complex it is. But anyway, it turned out it's all right. The same with Power BI. So when we say open table format, so the main one, Delta and Iceberg, and I will say probably Iceberg is the new standard. So just this week, it was quite funny. This week, basically, all the vendors, they all released Iceberg REST API, like all of them, in the same week. So Microsoft announced that they have one, and then day after, it was BigQuery, and the day after it was Snowflake. I would say maybe it's coincidence, but now like we have 5 vendors: AWS, BigQuery, Snowflake, Fabric, and Databricks. They all offer REST API for Iceberg, at least for read. Some of them offer write. But the idea is like if you are, let's say if you are an engine, if you want to build an engine, all you have to do is just support Iceberg and you will be fine. The difference between Iceberg and Delta, it's nearly for historical reason because it was developed by 2 teams, but it's the same approach. Like the data is in Parquet, and every time you install, like if you write new data, you just add new snapshot. In the case of Delta, it's just a JSON. And for the case of Iceberg, it's much more complex. They have one metadata and then which point to a manifest and manifest to a list of manifests. But it's the same approach. It's to say, just for fun, I like to call a glorified Parquet of glorified folder of Parquet files. Just think of it like that. And it provides some kind of consistency. Obviously, it's much more complex, but so because we have 2 table format, one trick is let's just give you the 2 metadata and then problem solved. And this is basically what Fabric is doing. Is if you want to read it as Delta, it's fine. You get your Delta like metadata. If you want to read it as Iceberg, you read it. And the thing is, metadata is very cheap. Like it's nothing compared to, and the data is the same. The only difference is the metadata. Probably that's the core of the presentation. So now that, let's say we agree that we have standardized storage, we have standardized open format. For me, that gave the opportunity for those new engine to make a difference. And again, if you are in data engineering, Spark is still the de facto standard. But in my focuses, for some reason, I have an obsession with smaller data and smaller hardware. Maybe I'm cheap. Like, I want just to consume like the minimum ever, just for fun, because it's quite interesting. Like, a lot of people, they try to show you like how big they want, but for me, I went to the other way. Let's say how much data you can process using the smallest compute ever. And in our case, because this is not specific to one platform, but for us, we have the smallest compute is 16 gigabytes of RAM and 2 core. And for me, like, I will show you that you can do a lot of that. Just remember, human went to the moon using, I don't know, like 4 kilobytes of RAM or something. So with Spark, basically, you will not get fired for using Spark. That's basically the standard. You can just use it. It's fine. Maybe there is a bit of overhead, but there are hundreds of thousands of developers, and it has like the best support for open table format. Maybe it's not the most efficient. It's not always the most efficient engine for smaller data, but I respect people just using Spark and saying, I'm happy with 10% or 20% of overhead. But if you have an obsession with optimizing to the maximum, there is new offering, and it's very, this space is absolutely very active. So one of them is DuckDB. Just a background, like all these are open source engines. The slight difference is now, like, you shouldn't say only open source. You need to know who own the code, if it's a foundation or a company. So Spark, it's Apache Foundation. Simply means is they cannot change the code. So it's by design, it's always open source. And if you are into open source thing, you hear some dramas, like there is a software that starts open source and then the company may do funny thing. Polars is a company, Daft is a company, Lakecell, it's a new company, CHTP, it's based on ClickHouse, Datafusion, it's an Apache software. DuckDB, actually, it's a foundation. It's a Dutch foundation, and the foundation has only one purpose in life, is to make sure that it's always open source. So, like, there is less risk, at least for companies, to make an investment. Instead of showing like the benchmark, this is just a subjective. And the way I come up with this is it's very selfish. I just basically show the stuff that I care about for my workload. And then I said how every engine behave. So your workload will be different. And one thing I learned is maybe the tragedy with data engineering is that everything depends on your data, on your data distribution. So when someone say like with small data, with big data, that depends on your exact use case. So the rule of thumb is, if you want to test on your data. There is no universal benchmark. Something that I may like, other people, they will find it totally not useful information. And I will show this in a minute. So for me, what I care about is, because I read a lot of CSV, that I have a use case, there is like a very dirty CSV with like variable number of columns. So if you deal with variable number of columns, you know it's a pain. But if someone, his CSV is sweet, so I think what you're talking about. So the experience is, basically you judge those engine based on your experience. If your CSV is nice, there is no variable number of column, then fine. But if you have, then it's problematic. The bottom line is, no one gets fired for using Spark. DuckDB and Polars get in there. There's quite enough community support. Python people tend to like Polars. I'm not a Polars person. And the reason is I'm not really into Python. But one thing, to be fair, their API is fantastic. Like if you play with Pandas, like Pandas API are just strange. But Polars, you can feel that the guys spend a lot of time making sure it's very user-friendly. And actually a lot of, I think users, they love the API itself. Daft, it's more into this AI thing. They tend to care about image and stuff. I like Excel because the guy is very clever. Instead of creating an engine from scratch, all he did is he took Datafusion and he took some other library and he said, I will just make Spark but totally native. And he built this engine. So I wish him well, because I like this idea of not reinventing everything. CHPD, it's ClickHouse. Obviously, Peter, I think, knows very well ClickHouse. It's a very mature offering, but the thing with ClickHouse, it's for very big data. And I think they noticed that a lot of people like to play with Python. So this one started as an independent project from someone in Singapore, and then he got hired, and now it's an official ClickHouse project. Having said that, this is an example from DuckDB, and they're upfront. Yes, open table format is becoming standard, but the support is not as mature as Spark. Forget DuckDB for some reason. They built their own table format. Let's not go there. That's a talk by itself. So let's just focus on iceberg. It's OK. Delta is not there yet. And for me, I use Delta, but it's just a hack. I use Delta package with DuckDB and then exchange data using Arrow. But the native is not there. Usually people ask, where is Pandas in this talk? I don't think is, I use Pandas, but if you're starting a new project, there are better options. Because the problem, I think the issue with Pandas is people try it, and then they get out of memory. And then they get the impression that to do any decent work, you need a distributed or a bigger system. And the issue is you just need a better engine. And there are better options. Having said that, Pandas was downloaded 300 million last month. So I don't know, people like it. So actually, that's what matters. It's not what I think about an engine. It's clearly people like to use Pandas. So this is an example of, I just put it on Twitter, because I love Twitter. And I got this answer, which is fantastic. He said, I don't care about your diagram thing. I don't use SQL. So I don't know what you're talking about. And I find it fascinating is although we tend to think of data engineer and data engineer as something rational, actually it's not. It's more about your personal preference and habit. And so if you don't care about SQL, so probably you will think Polars is the best thing ever. There is another tag. It's called Arrow. This is in the background. And this is fantastic. Arrow basically, and by the way, it's from the same guy who created Pandas. And basically, it's a standardized way to exchange data between process and engines. So before, let's say, if you have, in Python, you have two programs, and you want to move data from one program to another, one way you can just write Parquet and read it, or write CSV and read it from. But with Arrow, and it took nearly 10 years to become standard. And it's a standard, it's everywhere. Like you are using it, if you use Python, you are using Arrow even without knowing. And for example, in my case, I use it if I want to write Delta. I just export the data to Delta Writer, and it's totally transparent. So this one is awesome. One of the I would say, like even Spark initially was a bit hesitant to adopt Arrow for some reason. And even Spark had to adopt it. So the fact you made it to Spark, it means you made it. Now for let's do like some real benchmark with numbers, and we'll run some queries. So one of the benchmark is called TPCH. It's the most unrealistic benchmark ever, but it's a standard, everyone uses it. But what I like about it is like one example, like all the keys are integer, like reality is, which sounds quite funny. In real life, people just join on text. I know it's bad practice, but this is what happened. And it's actually, it's proved. Like I think Snowflake made the paper, and they found, I think like 40% of their queries are on text. I do join on text all the time. So, but still, what's interesting about the benchmark, it's standardized. And what I'm more interested in is the direction. Is like the evolution of the progress, not the benchmark itself. So I tested those engines, and always using the 16 gigabyte. And here it's the SF means scale factor, start from like 1. Every scale factor means 6 million. So I start from 6 million to 167, which is 1 billion. And I tested all those engines, and when it's small data, it's fine, it works. Keep in mind it's only 16 gigabyte. And the more you increase the data, then you will start seeing problems because the engines start failing. And the reason DuckDB works just fine, because it supports spill into disk. And it's like a nightmare. So for example, Pandas, the way it works. Pandas, if you have 10 gigabyte and you want to analyze, Pandas is not very clever. It will load the whole 10 gigabyte. And then let's say you have a table for the whole world, and you want just to analyze, let's say, Japan. For Pandas, it will load everything and then just filter Japan. This is extremely inefficient, because if your table is massive, it means you will get out of memory. Keep in mind, the most precious thing is still memory. But DuckDB, the way it works, it will just load only what's needed. Basically, it will push all the filter to the source. And even when it pushes the filter to the source and the data does not fit memory, it will just load the data and then spill to disk. This is not like something revision, like this is one noun, but usually before it was only commercial data warehouse that could do that. But now we're talking just Python package that can do that. That's why for me they are like proper database. So yeah, it's for up to 1 billion, and it didn't crash. Obviously, it's very slow. Here it's 175 seconds. But with 16 gigabyte. So the next time when you get out of memory, yeah, there are two approaches. Either you add more hardware, or your first reflection is, my engine sucks. That should be the right. Even more impressive is the direction. So this is a benchmark for 100 gigabyte. And I started in September last year. And this horizontal bar is the state of the art, like closed source, commercial, blah, blah, blah. This is like the best you can get. And here, DuckDB. When it started, it was like 10 minutes, and then it was like for nearly a year, 8 minutes. And suddenly a massive improvement from 8 to 4 minutes. And the reason they got all this is just cache. So one of the tricks is if you read data from object store is slow, all things considered, compared to disk. And all they did is just add cache to their engine. So now instead of every time you run a query, it will go to object store, which take time. Now, they have a buffer pool. Basically, the first query will be slower, but the second, it will run from either from RAM or from disk. So that's like a massive improvement, and I would say it's quite competitive with the state-of-the-art engines. Here, I'm just trolling. This is not realistic, but just for fun. I took like the biggest node we have, and it's 64 and half terabyte. Actually, this one I was trolling. Like I was on LinkedIn, and someone was saying big data for like 3 gigabytes or something, which is nonsense. So I just put 10 terabyte. So people just stop talking about this scale. It's like I'm sick of people talking about scale. Like there is a lot. If you take DuckDB, there is thousands of problems, but scale is not one of them. So I ran it for 10 terabyte. So I don't think the scale is your biggest problem. There are other issues, but scale is not one of them. So the one interesting discussion is like, what is even small data? So just try to have like common understanding. So if data fit in memory, that's fantastic. That's the best you can. It's the fastest. Everyone is happy. Even it will work with Pandas. If it doesn't fit in memory, then fine, it can spill to disk. It's good in the sense that you will not get out memory, but it's slow. Spilling to disk slow. There is like the worst case scenario is that you can split to remote storage, but that thing is really slow. Like, don't try it. Just increase the hardware. Having said that, out of memory still happens. Like I'm not saying it's a solved problem. The engines are not perfect, especially sometimes when you do join between like 2 tables, and the query planner doesn't even know that when it does the join, like it will just explode, and you get some massive intermediate result. So sometimes it does happen, and basically the issue is based on the operator. So sometimes someone asks in a forum, I say, can I process billions? This question doesn't have much sense, because if you are just reading, I can read trillion using 1 gigabyte, because all I'm doing, I'm just reading and storing. But the issue is if you do sort, and sort is a nightmare, because in order to sort, you need to see the whole data. Or if you want to do group by. So the reality is that you should ask yourself, like if someone tells you what's big data is, what's the complexity of your pipeline? That's really what matters. So streaming operators are awesome if you want to filter. So recently someone made the test on a terabyte, but the reality the test was just filtering 1 gigabyte. So it was interesting. But if he did the group by or sort, then you will see all kind of funny stuff. So sort is not your friend. Sort is the worst. Just don't do order by unless it's really needed. Or group by. And group by especially if you have a lot of distinct value. So those guys are killer, especially sort. But if all you are doing is just reading and storing, then there is not, the word big data doesn't have much meaning. So here an example using Daft. I like their, let's see if it works. Sorry. This is the first time I touch MacBooks. Yeah, just for some reason I like their. Yeah, I like their stream. I just find it mesmerizing. And this one is still like 16 gigabyte, and it's processing how much? 41 million, and it's just streaming. Like it's the amount like of RAM used. It's only 30% from 16 gigabyte. It's like it's very beautiful. Like try this with Pandas. It's just horrible. Pandas will just load everything and you get out of memory. But here it's just very smooth, and it will just process it. But again, here I'm just doing a simple read, filter. I'm adding column. If it was group by, obviously it will be harder. Daft does support streaming to disk too, spilling to disk. So here I've done another test, but this one is reading from CSV. So it's a more data engineering thing. The first one was data. I'm more data analyst. And here I'm just, I have 150 gigabyte of dirty CSV. Dirty in the sense the CSV is, it's not even CSV actually. It's like 5 tables on top of each other, and they just put it on CSV. So there's no like clear scheme or anything. And it's very hard because a lot of engine, they get confused if the header has less number of columns than the core of the CSV. You get weird stuff. So I tested with 150 gigabyte, and you see how the engines. So you have DuckDB and Daft. They process it just with 16 gigabyte. I think that's fantastic. This is only like with 2 core, so here's 16, 32 gigabyte, and so on. Obviously, the more you add hardware, then all the engines just work fine. But the fact that they worked just with 2 core, I think that's magical. It's the same graph, but here in live, and you will notice something. Adding more hardware, it's not linear. You reach a point where your bottleneck is not the CPU. So adding more compute doesn't help you, because in this case, the bottleneck is the bandwidth from object store. And there are like cases where, as far as I'm concerned, that's maybe a very clear case where distributed has an advantage. Because distributed, you have a lot of basically compute, and every compute can access independently the object store. It means you may get more bandwidth from your object store. So here, if you have a job, just make sure you are using, because the objective is to get your CPU to the maximum. That's your objective. Like especially on the cloud, all the jobs will finish. It's just how much they cost. So try to maximize your CPU. And just adding more compute is not automatic that you will get better result. One thing I don't like about Python, it's a mess. There is no standard API. So just for fun, this is all just to give an example, just to do this benchmark. There is no standard way to export data frame. Every engine will have a different. So one is DF, the other one is 2Arrow, 2Panda, and the other is collect. And I couldn't find just a common method where all the engine works. So this one is a pain. This is just an example of doing the same. It's the same job. This one is DuckDB. It's SQL. And this guy, Polars, totally different, but it's the same thing. It's close enough, but it's not the same, just to know users. You have Spark here, more or less the same. So definitely there is a problem. And that's one of the reasons I respect some people. They will say, you know what, I'm just using Spark API. Life is too short to learn new API. I don't care. I do respect that. Or someone say, no, I'm just using SQL. So because like people recognize that's an issue, is one of the solution is they come up with a standardized. And IBIS is again from the same guy who made Pandas. So he create Pandas, he create Arrow, and now he's create IBIS. By the way, I find it ironic. Like the guy who create Pandas has no problem of using something else. And sometimes you find data engineers like really, it's making it nearly religion. So the guy who made it has no problem. And his approach is, let's separate the API from the engine itself. So he come up with this standard API, and it doesn't matter what engine you use. And the idea, if you write in IBIS, then the same code will work anywhere. So that's the theory. But because it's an open source, instead of one solution, we have IBIS, and there's another guy, he come up with another solution. It's another standard too, Narwhal. So it's more or less doing the same thing. So now we have two. Okay, now we have three. And the third guy, they said, okay, let's do the same, but we'll do it in SQL. So I'm trying to be funny here. It's very hard to get standard. And maybe that's human nature. Maybe that's okay. Maybe like that's why we have a lot of language in real life. Like you cannot have just one language. And this is just me personally, after spending a lot of time on this stuff, is just learn SQL. For me, instead of trying for all those engines to agree on something, just learn SQL and probably you'll be fine. That will be my, obviously, you guys are more experienced than me, that if I have to give an advice to my son or like someone who's starting, I say, just learn SQL. Don't. The market is not mature enough. It's, there is no way that people will standardize on anything. So that's was the theory. I use this to implement like a real life job. And what I like about this job is it works anywhere. Obviously, it works in Fabric, but you can run it in your laptop or in Colab or whatever. It's just using Python. And it's processing data from Australian electricity market, and the data change every 5 minutes. And Python is fantastic. This is a screenshot from an actual runs. It runs every 5 minutes. I probably will say there isn't anything particularly interesting. Again, this is using the smallest compute. That's like my trick, just making sure that something complex works only with smallest compute. Again, I've written this code in so many different languages, and then I reached the point just in SQL. People have been doing this for like 30 years, and it works. By the way, you can download that example. And yeah, if you have a question.
Round of applause.